So now we need to discuss solving problems using proportionalities. And this applies anytime you see a question that says, if something doubles or triples or quadruples, then how is this other variable affected? So you have a cause variable and an effect variable. And in the example I've provided you, if you quadruple the centripetal force while spinning a yo-yo around in a horizontal circle, if you quadruple the centripetal force while keeping the mass and radius constant, how will the speed be affected? And I have a diagram down here of our yo-yo spinning on a string. We have the tension force towards the center, and it's spinning in a counterclockwise direction with speed v. In this case, the tension is the centripetal force. That's what's causing the object to stay in a circle. So before you approach these problems, let's go through the rules, and then we'll apply the rules one by one, and then we'll work through the entire problem. So solving problems using proportionalities, there are 4 rules to follow. Number 1, you must choose an equation that has both variables, the one that you're changing and the one that's being affected. Rule 2, you will drop zeros and constants will become ones. Rule 3, solve for the affected variable, and Rule 4, you insert the variable that you're changing. So going through these rules one by one, we need to choose an equation that has both variables, the one being changed and the one being affected. But be careful. If any other variables are being changed in the equation, then the equation won't work for your purposes because multiple things are being varied. You can do that, but you need to make sure that you're taking into account how much all variables are being changed. And that will make more sense with the more of these you do. So we need to choose an equation that has the variable we're changing and the one being affected. We are quadrupling the centripetal force, in this case the tension, and we're seeing how that's affecting the velocity. So the equation we use needs to have velocity and centripetal force. And we want to see how quadrupling the centripetal force will affect the velocity. So we need to choose an equation that has both variables in it. Fortunately, there's only one, which makes this one extremely straightforward, not a whole lot of thinking to it. We have our equation. Rule 2, you need to drop the zeros and constants become ones. In this equation, nothing is zero. If I said the initial velocity was 0 or the acceleration was 0 and you were using one of those equations, then you would drop those terms. However, in this one, we only have constants. The mass is constant because the mass on the end of the string, the yo-yo, isn't changing when we quadruple the tension force. Also, we're not changing the radius. The only thing we're changing is the tension. So the mass and radius are constants, which means they become ones. So the mass becomes a 1, and the radius becomes a 1. And then when you work that down to the next line, you get the tension is no longer equal to, but is proportional to the velocity squared. Proportional to means if one thing changes, then the other thing will change directly. Meaning if we square the velocity, it will directly affect the tension. I don't want to get too much into the specifics without working through this particular problem first. But if you said your heart rate was proportional to the caffeine in your system, then more caffeine means more heart rate. So rule 3, we need to solve for the affected variable. And the initial problem said, how is the velocity affected? So that means we need to solve for velocity. And we're pretty much there, but we don't want v squared, we want just v. So to get rid of that, we have to take the square root. But whatever we do to one side, we have to do the other. So v squared and square root are going to cancel out, and you're going to find that the velocity is proportional to the square root of the tension force. And now we're already on the last rule. You need to insert the changed variable. In this case, we multiplied velocity by 4 times. So we need to insert that 4 times in for tension. I'm sorry, I misspoke. We multiplied the velocity. No, we multiplied the tension by 4 times. Excuse me. We multiplied the tension by 4 times, and we wanted to see how it affects velocity. So you insert 4 times in where the tension is. So now, square root of 4 times, and the square root of 4 times, the square root of 4 is just going to give you 2. So 2 times, and that's what you're going to do to the velocity. So whatever you get out from your right side of your equation is what you're going to do to the left side of your equation. So because we got 2 times out of that, we are going to essentially double the velocity. So if our initial tension was 80 newtons, and that meant we were spinning it with a speed of 10 meters per second, keep in mind I'm making these numbers up. If you instead used 4 times that tension, and you used 4 times 8, 320 newton force to pull it in, to have the same mass and radius, you would have to spin it twice as fast. So you would have to spin it at 20 meters per second. Now, some bonus benefits of this. It is faster if you take a little bit of time and work through a couple of practice problems. So after some effort, you'll get extremely quickly with these, and you'll be rocking off problems left and right. There's less opportunity for calculator mistakes. The equation is reusable because it's already solved. So with that previous equation, velocity is proportional to the square root of tension. If instead I said, okay, what happens if you multiply the tension by 16 times? Well, in that case, you would multiply by 16, and you would insert it for the tension. So the square root of 16 times is going to give you 4 times. So it's going to give you 4 times your velocity. And our initial velocity was 10 meters per second, so that would be 40 meters per second. Assuming that 80 newtons was multiplied by 16 times. Oh, numbers are hard. 80 newtons was multiplied 16 times. And when you multiply 80 newtons by 16 times, you get 1,240 newtons. 80 newtons, 1,280 newtons. 1,280 newtons, you would have to spin it with 40 meters per second to keep the same mass and radius in that circular motion. And in the next video, we'll go through a couple more practice problems, but this is essentially the process you need to do it. And I'll leave it on this page in case you need to copy any of these things down. Thanks.